If you've been scrolling through endless listings, comparing rack mount servers, and still feel like you might end up with a box that either overdelivers or underperforms, this review is here to clear the fog. I've spent the last few weeks digging into the Supermicro SuperServer 4027GR TRT, reading the technical sheet, checking community forums, and chatting with a couple of small business IT guys who actually run these machines in production. Link is in the description if you want to check the product details on Amazon. What you'll get from this video is not a glorified spec dump, but a look at the real-world trade-offs, the kind of workloads that make this server shine, and the scenarios where you might be better off looking elsewhere. First, let's talk about the shape of the problem that brings someone to a 4U, dual-processor chassis. You're either handling heavy virtualization, running a data-intensive database, or you have a handful of GPU-accelerated tasks that need a sturdy platform. The 4027GR TRT is built around Supermicro's C602 chipset and supports two LGA20112 socket CPUs, meaning you can theoretically pack 28 cores or more into a single rack unit. The headline specs sound impressive, but the value comes from how the chassis actually integrates into your existing data center workflow. Who should buy this? If you're a small to mid-size business that already runs a few virtualization hosts and you need to squeeze extra compute density without expanding footprint, this server is a solid candidate. It also makes sense for labs that need a test bed for next-generation Intel Xeon scalable processors, because Supermicro's modular design lets you swap out CPUs without changing the motherboard. Engineers who want to experiment with high-speed networking will appreciate the built-in support for multiple 10 GBE and even 25 GBE NICs that the C602 chipset can handle. In short, anyone who needs raw CPU power, flexible I/O, and the ability to hot-swap components will find a home here. On the other side, you should skip this if your workloads are modest. Think single VM web servers, basic file storage, or anything that could comfortably sit on a modest 2U or even a tower box. The initial cost of the Barebone system, plus the expense of two high-end CPUs and the memory you'll need to actually use that CPU count, can quickly outpace the budget of a small office. Also, if you're not comfortable with rack mounting and you don't have a dedicated server rack or at least a well-ventilated cabinet, the 4U footprint is more of a logistical headache than a benefit. Now, let's get into the practical strengths. One of the first things I noticed when the unit arrived was how straightforward the assembly process is. Supermicro provides clear labels on the front and rear panels, and the toolless drive bays make swapping in a 2.5-inch SSD or a 3.5-inch HDD a matter of a few seconds. This is a real time saver for anyone who frequently changes storage configurations for testing or for maintenance windows. The chassis itself is designed with an emphasis on airflow. The front intake fans and rear exhaust fans create a clear path, so even when you load all 12 drive bays, temperatures stay within the safe operating range for both CPUs and any add-in cards you might slot in. Another strength is the networking flexibility. The C602 chipset natively supports up to 8 PCIe 3.0 lanes per CPU, which translates into plenty of room for dual 10 GBE or a single 25 GBE adapter without sacrificing other expansion slots. I spoke with a colleague who uses the same model for an edge compute node, and he told me that the ability to add a dedicated NIC for storage traffic while keeping the management network separate helped him shave off latency spikes during peak loads. That kind of concrete separation isn't just a feature, it's a way to keep your critical services stable when the network gets noisy. Memory capacity is also a big selling point. The board offers 16 DIMM slots, 8 per CPU, supporting up to 1 TB of DDR4 RAM when fully populated. For workloads that need large in-memory databases or heavy virtualization with many VMs, that capacity is a real differentiator. Moreover, Supermicro's layout lets you install the memory modules in a balanced configuration 4 per CPU right out of the box, which maximizes bandwidth across the NUMA architecture. However, there are a few practical weaknesses that surface once you start using the system day-to-day. Power consumption is the most noticeable. Two high-end Intel CPUs, a full rack of drives, and multiple fans can easily push the unit past 500 watts under load. If you're operating in a data center where electricity cost is a factor, that draw adds up quickly. Users have reported that the power supplies, although reliable, generate more heat than the chassis can expel when the server is fully populated, forcing you to lower ambient temperatures in the rack or to add additional cooling. That's something you'll need to plan for in your cooling budget. The other drawback is the lack of integrated management tools beyond Supermicro's IPMI 2.0 interface. IPMI is functional, but it's not as polished as the remote management solutions you get with some competing vendors. The web interface can feel clunky, and